Assalamu alaikum. So today we're going to continue with our leftover parts where we ended up in the last lecture. So we were doing up until DNA. So we learned about the DNA, their structures, and sort of how they form specific bonds. So we also saw that the phosphates they form bond with sugar, also sugar here. So those sugars in turn actually form bonds with the nitrogen bases. Nitrogen bases are what? There are 4 nitrogen bases so far we know, like in our context, they're like adenine, guanine, thymine, and cytosine. So guanine is supposed to react with cytosine. So if there was this, let's say guanine G, then it will form sort of triple bonding with cytosine. And this sugar, if let's say it was bonded with adenine, so A, it will form sort of a double bond with the thymine. Thymine represents as T. And the other part also forms bond with sugar, let's say. So there is this sugar, okay? So that's how, that's what so far we learned. Now, let's do a couple of examples today. So let's say there's this substance given to us. Substance will fill up a table. So the table consists on one column head as substance written. So substance such as, for example, adenine. Then we have alanine. We have aspartate. Or is it aspartate or aspartic acid? It should be, just a minute, it should be aspartic acid. I have written something wrong here. Just give me a second. Isn't it? Yes. Aspartic acid. So that aspartic acid part is aspartate. So that means it contains an aspartate ion, most probably. So aspartate. So remember aspartic acid, like carboxylic acid, we say the carboxylic acid, like it has something, this structure. So what does this represent? The carboxylate ion, isn't it? So that sort of thing. It is aspartate ion, you can say. So now, and the other component is, let's say, phosphate is given. Okay. Now, in the following column heading, they are saying that which one are protein synthesis, and which one is the formation of DNA, That means, like, which one helps in the formation of DNA, or which one actually helps in the formation of DNA, and which one actually helps in protein synthesis. Protein synthesis, which one? Forming that protein molecule, or the protein polypeptide linkages. Okay, so that means proteins are what? Proteins contain that amino acid. Amino acid has that large linkages. So that chain is known as that protein. So that process of forming protein is known as what? Protein synthesis. And formation of DNA is, what do we know about formation of DNA? So I know here is the question a bit tricky. So this sort of questions are going to come, but you have to understand the language of the question. So protein synthesis is formation of protein. Now remember, formation of proteins, like the polymer of protein is formed from the monomers of what? Amino acids. Amino acid has that R group, and depending on that R group, we have that what? We have alanine, aspartic acid. We have then glycine. We have cysteine. We have serine. We have lysine. So those are the components of, or the type of monomers of the protein molecule, a protein polymer. So those are used in formation of protein, isn't it? That means see which one of them resembles from the monomer of protein. One is this alanine, isn't it? Alanine is from our protein synthesis part. And another is what? Aspartic acid, from where this aspartate ions come, isn't it? So this is our protein synthesis monomer. And the rest of the components, see adenine, we just learned in our last lecture, as well as like we know that in formation of, like we just saw here as well, the like all the components are also measured, like represented here. One is what? Sugar, phosphate. Then we have guanine, we have adenine, we have thymine, we have cytosine. So that means what? Adenine is part of is helped in the formation of DNA. So adenine and phosphate is also helped in formation of DNA. This is actually the DNA structure. This is one of the DNA structure. Okay, this is one of the DNA structure where the strands, where we used to see these strands, isn't it? These strands. These are those strands. These strands are made of sugar and phosphate. These strands are made of sugar and phosphate. However, in between, we also saw that there's this bond. This bond is this one: glutamine, cytosine, adenine. Then we have thymine. So this bond is, or this sort of linkages is formed due to those portions. Now, most probably in last lecture, I described about the initial structure of DNA, or deoxyribose structure. So the deoxyribose structure I showed there, it was something looking like this, isn't it? Let's see again. It was something looking like this. Okay, this is what? This was actually the sugar part, or deoxyribose actually. This is the sugar or deoxyribose in the DNA component. So this whole part is actually, here we have or the name of this sugar, or this deoxyribose is actually 2-deoxyribose. Why 2-deoxyribose? Because we have two oxy group, OX, OH group here present. So 2 OH group are present towards the towards the ending side. Towards the ending side, we have 2 of the OH groups present. So 2 deoxy, so deoxidized. Why? Because this part is sort of deoxidized, and deoxyribose is sort of the way the name is being given here. And I don't know the actual detailed structure, but that's what makes sense of me. It might be something else, but yeah, though they are not going to ask in the question why this name is given, or what is the structure, but this is helpful for you to know, okay, this is the structure actually in the deoxyribose. They are also most probably not generally they don't ask also regarding the structure of the sugars, sugar, but yeah, it's better to know. So now let's do another example. Let's say we're given the in one of the column heading, we are given amino acids. We have amino acids on one of the column, then we have the structures and the other column, and we have the types of interaction. Okay, so we have, let's say, alanine or alanine, then we have cysteine, then we have lysine, finally we have serine. Now the structure you are asked to draw, as well as the types of interaction you are supposed to draw. Okay, so generally these structures, okay, these structures, they're given in your data booklet, so you can take help from there draw it, but I would suggest to actually, like, with practice you will eventually get to know. But yeah, what I'm trying to say is going back to data booklet sort of time consuming, isn't it? Like in terms of thinking, like let's say in the exam hall, because in exam hall you have very like there is the constraint of time. Right now you can, yeah, obviously go to the data booklet, but try to recall those, like what are the structures, at least those which are given in the like notes, because like or given in the lectures, because these are the only, you could say these are the parts, or these are the main types of amino acids which usually, or which mostly comes in exam. Okay, because these are the one which are included in the syllabus. Now I would urge you to pause the video here and do this trial, like do the thing, solve the question or example by yourself. Don't worry, if you can't, we will be doing it together. Okay, so here we have H2N, CH, CH3, CO2H. Okay, this is the structure present here. And then we have, like, this is the bracket, the part in the bracket, inside the bracket, that is the R group. Then we have H2NCH. Here we have CH2SH. That is our cytine, or sorry, cysteine. I'm really sorry. This is our cysteine. And we have lysine. Lysine is, okay, so since lysine has a bigger structure, let's draw it in this way. CHCOOH. Let's draw it in this way. Let's say, like, trying to make it clearly visualizing that what is the structure. And finally, we have what? Serine. Serine is H2NCH, CH2OH, CO2H. Okay. Now, what type of bonding do they interact, or what type of interaction do they perform? Here we have what? In the R group, an alkyl group. That means completely it's van der Waals forces of attraction. Van der Waals. Then we have disulfide bond, because here we have cysteine, so we have the SH group here, like the sulfur group here. Disulfide bond present here. Disulfide bridge could also be mentioned. The disulfide bond or the disulfide bridge. We have lysine here. It is hydrogen bonding, because due to the presence of NH or hydrogen group here. Hydrogen bonding or ionic interaction. Finally, we have the serine. Remember, this like these are not the total, like this is one of the molecule. Okay, so this might get like confusing that this is a part of that one. No, so there's two separate molecules. So this is one whole molecule, and this is the below one is the serine. So this is actually serine, and the last one is what? We have a OH group, isn't it? So this actually participates in hydrogen bonding. So in this case, you need to actually mention the unique one, the like highest possible force or highest possible attraction. Remember one of the example previously we did where we mentioned all the possible bonds. That was also fine, but in this case, like this sort of example is given so that you can distinguish between them. Okay, so which are the like unique or characteristic bonds between them? For example, alanine, that only forms van der Waals forces of attraction, and that is the only bond it forms. Cysteine, it forms disulfide hydrogen, it can form disulfide and other sort of bonds it can also form, but specifically disulfide is the strongest bond it can form, isn't it? So disulfide bond is present here. Lysine, it forms hydrogen bonding, as well as it can also form or participate in, let's say, ionic bonding. But since like we have to distinguish between others, like let's say, like what they are trying to say, that if we have, let's say, two of the molecules in the same structure, so alanine in this case, this is the structure, and we have another alanine, like, so what is the bonding between alanine and another alanine? Van der Waals force. What is the bond between cysteine and another cysteine? That is disulfide bond. What is the bond between lysine and another lysine? So since there is a 2 NH2 group, So there's this NH group and there's another NH group. Okay, so these can have like sort of the hydrogen bonding in between them. That's also possible. So hydrogen bonding. Also ionic interaction is like mentioned, like eventually it is mentioned. So either one you write is completely fine. So they're not going to cut your marks. So whichever you want, you can actually write it. Because previously we wrote like which one, like all the one we mentioned, isn't it, previously? So here, either one you write is completely fine. In the previous, like in the last class example, most probably in the last class. So just a minute. So in the last class example, we wrote like, they were like all of them written, isn't it? Here you don't like here, right, or any of the question, you don't need to write all the one. Which one is present? For example, if you write like simply, let's say hydrogen bond, you have written, that's also correct. You have written ionic bond, that's also correct. Don't like, you are not required to write both of them. So it's better to write one of them. So whichever, like, but write the bonds which are actually present in them. Okay, this is hydrogen bonding. And yeah, so that's it. Let's do another example. I hope like these are clear. If like whatever bonding are there, if it is not clear, go back to the last lecture. Also see the notes and like revise the contents, and as well as go back to AS contents in order to see actually what is actually hydrogen bonding there. Like there is actually in detail given like what is actually hydrogen bonding or how this hydrogen bonding looks like. Okay. Now the next example is we have these three molecules, let's say. This is glycine, or let's say this is named as GLY. This is serine. Let's say this its short term is given as SIR, and this is valine. Let's say the shorter form is given as val. Now they're saying how many different triplet can be made using 1 mole of each of the amino acids like shown. That means, yeah. So how many triplet can be made using 1 mole of each, okay, of each of amino acids. Okay, now let's see one thing. Let's say we have glycine first. Okay, let's say we have glycine here. Okay, initially let's say we have the glycine here. Yeah, so this is NH2. Let's say like the first structure is gly, SIR, and val. Okay, we are trying to make bonds in this structure. So glycine bonds with serine. Then we have what? We have so from here there will be the ester linkage. Okay, and there we have the other portion. Then we have this carboxylic acid part, from where it will react with our valine. So we have valine's NH group here, and the alkyl group that, or the R group there, and we have finally what? The carboxylic acid group. Okay, this is one of the structure, isn't it? This is our glycine, this is our serine, and this is our what? Valine. Okay, so this is the structure of one such molecule. Now they're wanting to know what type or how many types we can form in such manner, or let's say a different combination. Another would be let's say gly, gly, val, and serine, isn't it? Another could be what? Let's say initially we have serine, then we have glycine, and we have valine, or we can, let's say, the other molecule could be what? Serine. We have, let's say, instead of glycine, let's say we have val, then glycine. Then we have another molecule, let's say, initially valine. Like here, what is happening? If we change one of the molecules position, obviously they're going to change. Let's see in detail, like let's see the structures. So let's initially we do have the glycine. So NH2 is present here. This is O, there's O. Now, when we have glycine and valine, valine is this. So valine's NH2 is going to react. So that O will be gone. NH2 is going to come here. This is the valence part. Okay, so amino acids reacts between which parts? The amine group and the carboxylic acid. So valence amine group is present here. Then we have this alkyl group, and we have, let's say, this carboxylic acid. This carboxylic acid in turn will react with the serine. Serine's which portion? This carboxylic acid will initially likely react with the main portion. Okay, we are not concerned with the side chain in this case. We are not going to consider the side chains. In serine C, we have wait, did I make some mistakes here? Okay, so yeah, I made some mistakes here. In serine C, we have what? We have used, instead of that amine group, we have used the alcohol group. But that shouldn't be the case. We should have used the alcohol group here, rather. Okay. I don't know what is. Just a minute. Give me a second. Yeah. So, why is it doing like this? I don't know. Okay. So, yeah, as I've mentioned, like alcohol part was what? Like which one were the I should have done this before. Like which one are the alkyl group? Here, this imaginary H here, that's an alkyl group, isn't it? So we don't need to consider that here in this case. Like we don't need to write actually in detail, but that's the case. Here we have this one as the alkyl group. Here we have this one as the alkyl group, isn't it? So those are not going to be considered, Barco. We are not going to be concerned of those components here. Rather, we will be concerned with these parts here. The next parts will be actually shown in the next here. In the next part, we actually, there should be a nitrogen actually here, and the rest of the R group should be, let's say, yeah. Okay, so I'm sorry, I forgot, I didn't notice there that I actually forgot myself that amino acid. So we should actually consider the carboxylic acid and the amine group here. Okay, so that's actually the cases. So here also we have this carboxylic acid, and the other portion is which one? Serine. There's the valine and there's the serine. So serine, which portion is going to react? The NH2. So NH, and there is this alcohol group is present there, isn't it? Yeah, there's a CH2 group as well, isn't it? So I'm making some mistakes again and again. This is OH. There's this carbon here, so there's a slight bend there. Carboxylic acid, yeah. That makes much more easier. And we have this, let's say, the carboxylic acid. Okay, so here we have this peptide linkage. Here we have this peptide linkage. We must have this peptide linkage present here. Okay, this peptide linkage is there. Okay, so if we would have concept, obviously, the inner structure or the inner molecules could have actually reacted with, let's say, like this R group would also could have been like reacted with this portion. But then we would have like thousands of like such molecules could be there possibly, okay? So we don't know which one is going to react with the like the main chain. So rather they have given us a constraint. The condition is said that only the main chains portion, the amino acid main chain part, what are like which with whom they are going to react, okay? So that there we got our second molecule. Let's say the third molecule, we have what? We have serine, glycine, and valine. So serine is which one? Serine is, let's say, this portion. We should have the NH2 group here. NH2. The other portion is going to be present as like the R group, so OH. Then we have the double bond O, and this carboxylic acid should react with, we have glycine here, so NH2. So NH should be here, and we have this just simple hydrogen in this carbon, so no need to show that hydrogen. And the carboxylic acid again, and finally we have this valine. So valine's NH2 or NH group should be bonding here, or amine group. Finally, we have this, let's say, the alkyl group, and finally the carboxylic acid, okay? And this is the third type of molecule. So we have this amide linkages present here, okay? I hope this is clear for you now. Let's say the fourth molecule also serine, but with serine we have valine now instead of glycine. So serine or serine, whatever the molecule is, it's difficult to pronounce such molecules. I don't know why do they like give such names. Who are these scientists? I wanted to meet them. So NH2, and we have, let's say, this OH group present here, and we have this carboxylic acid. Remember, you can draw it in this way, that way, like whatever way the bend is given is completely fine. Your bend is correct. Just you have to remember the number of carbon and hydrogen and oxygen, like the like nitrogen, like they are same. Okay, the molecular formula, I mean, the number of components, the number of atoms should remain the same. Other than that, whatever shape you draw is completely fine. If they are able to understand, you're good to go. Then we have the carboxylic acid is already given. So this serine is going to react with valine, valence NH2, so NH. So that means we must have a peptide linkage. So this is the alkyl group. We have this carboxylic acid again, then amine reacts, like the glycine amine is going to react here. Finally, we have this carboxylic acid. Finally, we have this serine, valine, and glycine. Then we have, let's say, valines with serine and glycine. Okay, so let's say initially we have valine. So valine portion is, let's say, the initially NH2 is given here. You could also have started with, let's say, OH, like the other way. Okay, let's say instead of drawing it in like this manner, that carboxylic acid on the right, amine on the left, you could have also drawn it on the like carboxylic acid on the left side, amine on the right side. Completely fine. In that way, you will keep on following. Okay, like if you would have drawn it in this way, and let's say this is the alkyl group and this is the amine. Like you have like thought of doing this. That's also completely correct. Okay, let's do it in that way. Let's erase this one so that it makes it easier for us. So this NH is going to react with the carboxylic acid of serine. So carboxylic acid of serine is which one? This part. So we have the alkyl group there, sorry, alcohol group there, and finally we have NH2 group. So there's this NH, and we have the carboxylic acid of whom? Carboxylic acid of glycine. So glycine's carboxylic acid, and we have the NH2. Okay, so that's how it works. See now, like instead of CONH, we have what? NHCO. But see, the pattern repeats: NHCO, 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 NHCO. That's what peptide linkage means. Like it is going to repeat. It's not going to be like once NH, like in the same molecule, you won't see here you have NHO, NHCO, but you won't see that here we have CONH. Like you would see, let's say if you saw NHCO first, you won't see in the next like bond CONH. That's what like peptide is saying, that you will see just simply NHCO, NHCO. or you would see CONH, CONH. So it's preferable to give, let's say, like CONH, like in this manner. That's why we are drawing it in that way, CONH, COH, like CONH, CONH. In that manner, it was like preferable, but your one is also like this one would also be correct. Okay, you don't need to worry here. This is also fine, completely correct one. You're going to get marks. Now, there we got our fifth one. Finally, we have our sixth one, which could be valine. Then we could have glycine immediately, and finally serine. Okay, so what could be the molecule? Let's see. So NH2. Here we have, let's say, COOH, carboxylic acid part. So here the H goes, and glycine's NH bond will be coming here, NH. So we have this carboxylic acid present here, and the amine of the serine is going to be present here. Finally, we have this alcohol group as the R group, and we have this carboxylic acid. Okay, so this is our valine serine, glycine and serine. So see, in how many possible way we were able to arrange. One was glycine serine valine, glycine valine serine. Then we could have serine glycine valine glycine, and finally we can have valine serine glycine or valine glycine serine. Okay, so we can have, like, let's say GSV, GVS. We can have SGV, SVG. We can have VSG and VGS. That means what? If we have three different type of like monomer, we can have 3 factorial. This is a mathematical term. You would have observed, or you have seen in permutation combination part, that if we have 3 different type of molecules and their arrangement matters, which in this case actually mattered, like rearranging the structure changed the whole structure completely, isn't it? The whole structure got changed. If just simple monomer was placed, let's say, in place of second position, we place it on the third position, whole structure changed. That means if arrangement matters and we have 3 unique molecules, then like n number of unique molecules and the arrangement matters, then n factorial. That means n times n minus 1 times n minus 2 times, and it goes on until we reach what is that term? N minus 1. Wait, no, n minus n minus 1, until we reach to the point where we have 1. So like if you, let's say, if you subtract number from there, let's say you have 4. If we subtract each terms, so 4 factorial means what? 4 into 4 minus 1, which is 3, into 4 minus 1 is 2, is 4 into minus 1, which is 1. Then so n into n minus 1 into n minus 2. It goes on until we reach 3 to 1, or like until we reach 1. Okay, if it is 2 factorial, that means 2 into 2 minus 1, which is 1. So until we reach 1, this factorial works like this. Okay, so 3 factorial means what? 3 into 3 minus 1, which is 2, into 2 minus 1, which is 1. So 3 into 2 equals to 6. That means 6 possible combination. That means 1, 2, 3, 4, 5, 6. Okay, that's how was it. And actually the next question was to draw the triplets, like the triplets. So we actually drew the triplets here. Okay, so hope that answers the questions. Now moving on to the next example. If you didn't get the example over here, try to rewatch the part, rewind it, rewatch the part. Inshallah, things will be easier for you. Okay. Now, moving on to our next portion. Moving on to our next portion, let's say we have next example is, let's say we are given the structure of, again, the DNA. So we have phosphate. We have, let's say, here we have the structure of sugar is given in this way. So this is actually a sugar. Okay, this structure is sugar. Again, have phosphate. So they can actually draw it in various ways. Phosphate, and again, let's say we have sugar here. They have phosphate here. Sugar is given in this way. Okay, now this portion has this thymine T. This portion have is portion G, which is guanine. This is phosphate. Okay, then this thymine reacts, forms double bond with the adenine A, and this portion forms triple bond with cytosine. Isn't it cytosine? I keep on forgetting the name. Cytosine, yeah. Thank God I actually recall the name. Like I make a mess. Then there's this sugar, there's this phosphate, like it same strand, you can say, on the other way. Phosphate with the nitrogen bases. These are the nitrogen bases, each on